Hello, everyone, and welcome to another episode of a LinkedIn Live session brought to you by Accolite Digital. And we have done so many series in the past, and I would recommend highly that you check it out. And I think my personal favorite one was around GraphQL because it helped me use GraphQL on my blog. So I'll highly recommend check it out, and you can follow for more updates by going to LinkedIn's page for Accolite Digital, and you can follow the channel. All right, so let's begin. And before I begin, let me quickly introduce myself. I'm Meher. I have over 10 years of experience building front-end applications, mobile applications, using my favorite language, which is JavaScript. And I absolutely love working with JavaScript. And my journey started with my own startup, and then I worked across several domains of industry, e-commerce, banking, etc. And yeah, that was my journey with JavaScript. So let's quickly deep dive into understanding or looking at functional programming with JavaScript. So these are a couple of the topics that we'll be covering, which is we'll go through a basic introduction, then we'll try to understand what programming paradigms that we have, which are the popular ones. And the last two ones are the really important ones because they talk about the key ingredients in FP, which is functional programming. And then we'll take a look at JS code walkthrough. And trust me, we'll not do any kind of live coding because I really want to show you some snippets of code so that you can build a great mental model so that when you look at a problem statement, you can identify how do you solve a problem before you figure out how and what libraries and what frameworks you would want to use, because building an intuition for solving a problem is much more important aspect. For example, you must be used to using object-oriented programming, and you are very much adept with classes, object, inheritance, encapsulation. And whenever you look at a problem, you can easily classify your problem in those broad ideas. So what are these ideas in functional programming? Because if you go around, if you check on YouTube, and you read a lot of books around functional programming, you will mostly see things like map, filter, and reduce, which keeps on popping up. And that is, I would say, just 25% of solving the problem, because there are two main aspects of functional programming which gets missed. So let's jump into understanding functional programming, and let's create a great mental model here. All right, let's go to the next slide. So yeah, so why are we talking about functional programming? It's not a new concept. It has its own history in the past, and it is much more mathematical in sense. And if we look at the timeline, we can see that it started in 60s with Lisp. Then a lot of development happened, and it was 88 where Haskell, ML, and all these languages adopted pure functional way of doing things. So why do we want to do things functionally, right? We are able to solve problems using the patterns, which we have already learned. We learned about object-oriented programming. Academics taught us a lot about objects. So why do we care about functional programming? And before we answer that why question, let's look at the current landscape of frameworks. Okay, so we have React as one of the primary frameworks alongside Vue and Angular. But if you look at React, you would see that they moved away from class-based component to functional components. And if you've been following Facebook on their GitHub page, you'll see that they also have a project called as ReasonML, which is a bridge between OCaml programming language and React. So they want to explore the functional side of things. And there's another Rescript. And I think one of the key player programming language, not programming language, framework, I would call it out, is Elm. It kind of changed a lot of picture. It initiated a lot of interest in the community to start using a purely functional way of solving problem. So why do we care about functional programming? That's the question again, right? So so let's look at some of the programming paradigms that we have right now. So okay, so just to give a background over here. So when we are going through this slide content and learning about functional programming, I want you to move away from how of doing things, right? Because we all are problem solvers. We can solve problems. There's not a problem. There's no problem in that. The problem here is having a great mental model. So the mental model which we are going to follow here is using the lens of organizing your code. Because if we look at the history of how programming languages have evolved, you would see that initial programming languages used goto statement, right? They used goto statement to transfer the control of flow. You will have a huge file which will have hundreds of code, and then you will have basically at line number 20, you will say that I want to jump to line number 3 for executing something. Let's say if I want to repeat something, then I would say, let's say, go to line number 6. And that's how you would use this simple idea of go to, which is jumping your control execution. And that's how you execute this. That's how you basically organize your control flow. And this was pretty fine because your system started to become much more complex. Your systems became much more distributed. Computers were not just solving the problem, they were interacting with more systems. And with more systems, you need to build a code base that is much more easier to organize and make sense out of it. Because if you give me a line of, give me an application that just uses goto, it'll be impossible for me to read and impossible for you to share it with anyone. That will be a personal code for you to enjoy and look at it. But yeah, moving forward, some of the ideas picked up. The main idea which picked up was structural programming. And structural programming gave us 4 key ideas. The first key idea was that you will have sequential execution of your statements, which kind of already was with goto, but yeah, that was one of the primary fundamental units of your structural programming. Then if we look at the second aspect, it gave you conditional execution of your statements. You can use if and else. Now you don't have to use goto to go to line number 3 or 4 or 5, whatever that is. And then thirdly, you can use loops to repeat your statements. Again, you don't have to use goto because it's going to be really silly. So that's how your evolution started. And structural programming even had concepts of functions so that you can apply reusability, right? So while all of this is happening, you are seeing that we are finding ways to organize our code and write them in such a way that another developer or another team member can understand it. And if there are future updates in that, people can easily manage it. Because if I tell you guys, I would say personally, solving a problem is the easiest aspect. You all can do it. Anyone can do it. Like, give you a loop to sort it, you guys will be able to do it. But the way you solve it, will it be readable by another person? Can he continue on your work, which you have built upon? Is that the key question? And that's why we have 2 programming paradigms, which is imperative and declarative. And I know I have left the story at structural programming, but I'm going to continue this whole idea once we look at our code snippet, and I'll connect structural programming with object-oriented programming and then functional programming. But let's take a pause and try to understand the imperative and declarative side of things. So these 2 paradigms are kind of used a lot in Mixture. Like, your recipe of your application can have both of these things. I don't think they can completely exist exclusively, right? You will have to use some imperative things and you will have to use some declarative things. And the key problem with imperative way of writing things is because you rely a lot on your state change. And what I mean by state change is, for example, let's say you have a function and you have a lot of business logic written in that React component, not function, because React component is a function, but yeah, if you have a lot of business logic written in it, what you render on the browser to show the user, it depends a lot in what kind of computation you have done in that component, right? So that's very imperative. And even, for example, the way we usually solve our interview questions, the tricky ones, they all are usually imperative because you want to show or you want to figure out at every step what happens. And in declarative, the picture kind of changes a little bit. You want to hide away something. You want to make the communication easier by not playing with the state so much. Because if there's a pure functional programming language like Haskell, you will barely have variables, but you'll have identifiers. I'm not saying there'll be no variables, but yeah, there's a key difference there. We'll not go too much into details of that aspect, but yeah, you minimize the use of variables and you keep on passing the data, and you use composition in order to pipe your computation, right? And that's the whole idea. Plus, imperative way allows you, or imperative programming paradigm basically lets you do a lot of mutation. If, for example, you're solving a problem which has let sum is equal to 0 on top of your code, you're going to basically keep on mutating that sum variable, and you want to avoid that. Because if someone is going to look at your program, he has to go through each line to understand where the state change has happened. Even if your function name is getSum and it has some problems, people will have to go through it, right? So that's a pain. And declarative way of doing things avoids completely that. And I'm sure you guys already know what are the category of languages for imperative and declarative. So let's move on to the next aspect, which is about thinking functionally, because that's the key, right? I can tell you use map, filter, and reduce, right? But that's not functional programming. Functional programming is looking at a problem and finding what are the key players. And let's try to find the key players, and leave me a comment on the LinkedIn live session if you're able to, and let me know if you already know. Cool. Let's see some code in action. Okay, so this is where the action begins. Okay, so yeah, I was talking about structural programming, right? I hope you're with me so far. So we talked about executional, sequential execution of statements. Then we talked about having loops. Then we talked about having conditional statement. And this is a simple example, which we are going to actually transform from structural to object-oriented to functional, so that you can feel, you can get a feeling of it. I don't want to do live coding right now, right? You want to think functionally before you actually do it, right? And that's the idea. So we are doing a simple problem here. We have some data. We have a global state, sum is equal to 0. We are looping through the elements or the items in the data list, and then we are logging the sum. And this is so far good, right? We are able to use loops, if condition, etc. But there's one piece missing here, which is functions. Because if I have another data set, and if I did not have function, I will have to copy paste the whole thing, right? We love copy pasting, but not this kind of copy pasting, because that'll be too annoying. Nobody will approve that code. So without functions, we'd have to keep duplicating this code, and that's the idea. Functions solve for us. So if you have a function, then you can write your logic and reuse it. And you must be thinking, so where is this going right now, right? Because we can think about our problems in even more different way. For example, we saw the evolution from GoTo to structural programming. And then at some point in future, object-oriented programming came into picture. And why did we need object-oriented programming? So the idea of object-oriented programming came from the language Simula, which basically let you do simulations, right? And it, in another way, also simulated real-world computation models, right? Because you can use the real-world idea of blueprint of the car, then creating instances of the car. And that's the kind of idea object-oriented brings, because if we just have these 4 tools, which is if, else, loop, everything, it's still very difficult to understand your code base, because you have organized how the control flow is going, but you still have to get the whole idea of what is who and what is the relationship. So it helped us basically create a relationship between the entities in our problem statement. For example, if I give you a problem, you'll be able to say, okay, yeah, I'll create this class, I'll create this instance, and yeah, there'll be some inheritance going on, and I'll use polymorphism and things like that, right? Because it has become our second nature to use such key ideas. So what we are going to do next is we are going to transform this function if we apply object-oriented style to this, or pattern to this. Yeah, it's a style also. Okay, let's solve it using object-oriented pattern. How will this happen? Okay, so I've simplified it to a very high extent. Okay, so what we are basically doing is we are trying to find sum. So in object-oriented, if we take it as a very naive example, we'll probably create a math class, which will basically handle some way to show your data, and then you will attach your methods to the data. And by doing this, what are we basically doing is we are organizing how we access our data, correct? And if you look at the line where we are saying data set is equal to new math, we are basically creating a new instance of this class, which will have the capability to perform some operation based on the type of data that we have set in our constructor. And the second important idea of object-oriented programming, which is inheritance, lets you create even more classes. For example, you can create a vector class, you can create, let's say, a calculus class or something like that. And you see that the pattern is starting to emerge. It's more about how you are organizing your code, right? It's always been that. In GoTo, it was difficult. In structural programming, it improved a bit. But once we started using object-oriented, it simplified, it took over the world, right? And that's the key idea which object-oriented pattern gives us. And another interesting fact which comes to my mind right now is all those similar language which first introduced the idea of object-oriented programming. I think it was even way before C++. And at that time, object-oriented was not popular at all. The idea was there, but it was not widely adopted. And the wide adoption came once the C++ language came into the picture, and that changed the history of programming languages. Every problem in this world, I think revolves somewhere around object-oriented pattern. And I don't feel bad about it because it helped us a lot. It helped us look at our problem, figure out what is where in our application so that we can easily categorize the parts of our code base. So we are not just talking about control flow. We are talking about categorization with relationship to some real world examples, which makes more sense to us because we are interacting with the real world much more, right? Because real world does not work with the 4 ideas of structural programming. And that's the key idea which comes with object-oriented pattern. Now let's look at the next slide. So how do we solve this using functional pattern? Now this is going to be that aha moment. I hope it is going to be, or you will be like, what? Okay, so I know you might be getting around a lot of questions right now. You can drop in your question in the LinkedIn live comments section, which probably I'll take it later on, not to digress from the topic right now. So there are 3 key main elements in this functional pattern. What we have done is we have said, okay, we'll not establish a relationship between our data and our methods. Our methods are gonna be independent. They'll have all the liberty in the world. We want to give them so that we can reuse them in different contexts. And then we have said, okay, data can be isolated as well. And computations, which is basically your get sum and get product, they can be isolated as well. And then you must be looking at this one function called as run, which I have not defined in this slide because I don't want to confuse you guys. So think of run function as one function, which basically runs one function after the other in the order of right to left. I know it's kind of a little annoying to think in terms of right to left, but it'll make sense in the future episode, not in this session, because it'll be too much technical to cover in just one session. So we have this one run function whose job is basically to run one function after the other. And what we are doing is we are also using this one invisible function, which I think you get the idea. It's called as add 10. It does nothing. It just adds 10 to your data. And then we can see there's a second function, which basically is get sum. And then we see that there's a third function, which is called as save to database. So I have done some kind of separation here, which is not making sense to you guys right now. That why did we do this? What's the meaning of doing this? Making small functions and running them one after the other, and then they save to DB, which was not in the previous example, but I'll come to that point. So just stay with me. What we have done is our data is absolutely isolated. Our computations are isolated, and our execution of those computations is completely isolated. And there's this one new thing which I've introduced, which is called as save to DB, and we'll uncover it shortly. Okay, let me go to the next slide now. All right, now let's talk about the key ingredients, because then this is when it's going to make sense to you. Okay, so the key ingredients. What is key ingredients? You have to relate it to the ingredients of object-oriented programming, not one-on-one mapping. Like the ingredients of object-oriented programming is classes, objects, inheritance, encapsulation, such kind of those things which are in object-oriented. There are similar, not similar things, different things, but yeah, there are key ideas in functional programming. So we looked at this problem statement, and the problem statement has a couple of interesting bits. One was our data was absolutely separate. Then we had some computations going on, and then we had our run function. So the key ingredients in functional programming are your computations. And what are computations? Computations are things that basically are functions which do some sort of computation and return you back the value. Like any function that only depends on the arguments you pass to the function and you get back the value and it does not do anything else, that is computation basically. So let's now move on to the second key idea of functional programming, which is your actions. And the other one, which you must have heard so many times, which is the side effects. So I kind of myself don't like the word side effect, so I call it action, but yeah, they are used interchangeably. If you read a lot of text around functional programming and a lot of books, they will keep on using it interchangeably with actions. So what are actions? For example, if you have a function and that function is doing some sort of computation, and at the end of the computation, you are going to send an email with whatever the result was of that particular function, then that kind of an event which interacts with an external system is basically a side effect. And why does functional programming care about side effect? Is because you want to isolate the side effects. You want to keep them separate from your computations. Because if you look at your side effects, and if you can recall some of the examples, these are the places where a lot of your bugs and maintenance cost come, because you are always timing your side effects. Okay, let me give you a practical example of a side effect. Let's say you hit an API from your application, and you are waiting for the API to get you the result back. And at that time, at that particular moment, from the initiation of the API call until the results come back, that is the timing where you will create a side effect of showing the loader on the DOM. And that is what your side effect is. And now let's move on to the third bit. And the third bit is basically our data, which is much more simpler, because it's very easy for us to isolate our data from the computation and actions, because we know what data is. The data which you have in your database, the configuration files that you right now have in your React application, everything that does not do computation, does not interact with the system, is your data. And the beautiful part about data is it is inert, and it is absolutely timeless. And what other thing is timeless? Computations. I'll tell you why computations is timeless. Because no matter how many times you run a particular function, a function, let's say, which is getting the sum of numbers, it is always going to give you the same result back, no matter what. Once you have written a test case, once you have tested it, it's not going to give you a different result. And that's the kind of confidence you get when you have isolated your computation. An example to think about that would be, look at your utility library, which you have in your React, Vue, or Angular application. How many times do you go and change some logic in your utility library, like functions like debounce, throttle? Either you are taking it from an external library, or probably as part of an exercise and exploring it yourself, you have written them yourself. But it does not require your attention, right? Because you're mostly trying to play around with APIs, data, state, and everything. And that's where the most of your maintenance and bugs come from. So these are the three key ideas of your functional programming. And you must be thinking right now that there's a fourth one, composition. And although composition is understood implicitly, like, you are going to use the compose function, but I wanted to keep it here because to be very explicit about it, because we used the run function, which was basically composing our little mini functions to be running one after the other. All right, so enough talking about ingredients. How can we take a real world example, which is much more relatable to you, because we have taken a very typical example of finding a sum. So let's go to the next slide and let's solve a real HTML.js problem. And okay, you must be like, okay, this is not a real world problem. And I get it. It does not have that kind of scale. But I had to give you an example which uses very small minimal parts. Otherwise, we'll do our next session where we'll go live coding and we'll build probably a bigger application with functional programming. But okay, for this session, bear with me. We'll transform this code from this one state. I don't know what to call this state, but yeah, whatever the state is in, we'll transform it to make it consume the functional pattern. And what is it that we can do about this? So you can see there are a bunch of moving parts here. One is your span element, and then one is your home keyword, which is data. And then you again have your container, which is basically where we are going to put in this span and home. And the whole idea here is we are trying to put a navigation in our header. And this is what the simplest example I could come up with. And okay, so let's move on to the next slide. Let's look at what we have. Okay, so how can we improve this problem? We can improve this problem by creating a function like add navigation, which can take all the three dynamic parts of our previous code. Let me show you the previous code. The three dynamic parts, which is your home, because that is the data. Then you have your span, which contains your home label. And then you have a container. So these are the three variables. And if we go about solving it right away, you'll see that we'll put that variables in the function, do the little magic between the function body. What we'll do is we'll take the argument container, pass it to the query selector, and then we'll take the element type, which we want to wrap our data in, and then we'll give it to inner HTML. Don't do inner HTML. It's not recommended. There are better ways to do it, but we are just trying to learn how to think functionally, so we can do such exercises. And in the last line, you can see that it's mostly about passing the data, which is we are sending hash nav, span, and home. Okay, so far pretty simple. How can we improve this? So now, before I show you the next slide, which is the final transformation for how it will look functionally, I want you to think about future changes that can come to this problem statement. One is your container can change, which we can handle pretty easily. Second one is that you have element type, and element type can change from your span. Hold on a second. Okay. So element type can change from the span to UL and LI, and your UL and LI can also contain href. So once that kind of feature comes from your product owner, how are you going to change this? Probably you'll use this function, or you'll probably do something else. So let's think about what is that something else. And thirdly, you probably want to add more to your navigation, because right now your navigation just has the home link. You want probably about us, services, so many other things like that. So let's look at the next slide and see how can we transform this. Okay, so if you remember the three key ideas were computation, side effects, and data. And that's what we have done. The transformation basically isolates these three key ideas. And again, you must be noticing this run function, so ignore it for now. So if we look at why are we doing this, what we did. So if I'm just going to quickly jump back to the previous screen. In the previous screen, we had scalar values for your argument for the function. What I mean by scalar value is like string, numbers, anything which is not like, complex in nature, simple data types. And in this, the transformation of scalar values has turned into functions itself. For example, add to DOM is a function. UL is a function. Pick data is a function. And why are we doing all these functions? Because we want to apply three key ideas of functional programming, which is your data, computation, and side effect. We want to isolate them because the most amount of time you'll be spending in your application is basically dealing with the side effect. And if you isolate it, containerize it, keep it very away from your computation and data, then you'll have less time spending on bugs and future maintenance. And another idea is sometimes your computation and side effect can be together, but the idea is to minimize such computation so that your side effect functions are as lean as possible. So, okay, that's the key idea, why I did this and why are we doing this? Why did we make function? Because your add to DOM is interacting with DOM. And interacting with DOM is basically interacting with a browser API, which is not like a function which gives you a value back, right? You add to DOM and you just trust your browser that it's going to render it, right? So there's an external dependency, and that's why we have add to DOM isolated. Then you have UL function. So this function, the implementation of this function I have completely hidden because it'll take too much of space. But the idea of this UL function is that it will take your list from the last line, which is your add nav function, where we are sending home and about us. It will iterate through it and it will return you something which we saw in the previous screen. So I'm going to jump quickly to the previous one. This thing which you saw here, this computation, you must be thinking like, why is this computation? Because it's a simple concatenation, and that is a computation because you took two items, you did some magic, and you returned back this. So this $sign element type, or basically the idea of wrapping your home with a ULLI, is handled by the UL function. And the third function is basically pick data. Its job is right now nothing, but I kept this function because I wanted to show you the three aspects of functional programming, which is side effect, computation, and data. All right. So why is this useful? How can we leverage the power of functional programming? So if I go to the next slide, you can see that you can scale this problem. Let's say you want to add this navigation to the footer. What are you going to do? If you have that same one function which was adding navigation, that function will be like 100 lines of code by now. But by having your side effect and computation absolutely separate, you just don't have to care about what happens in UL, what happens in big data, what happens in add href. You can just focus on figuring out where to go what. And this is the kind of flexibility you get with add to DOM. And what we have also done in this case is we have used this one function which is called as add href. So add href is going to take your data in and it is going to add link. And that's what we have added in our new data structure. So you must be thinking right now that if these are functions, where are the parentheses? Where are the arguments? Why these functions are just written like that, right? So that magic is completely handled by this one function in functional programming, which is called as compose. So I'm not going to go much deeper in that, but I'll just give you a little gist. So compose function basically handles that part for you. Because if you look at addNav function is executed with this data. This data will be consumed by pick data, and then pick data will give the same data back to UL. UL will transform it, wrap it in your ULLI. Then it will give it to href. Href will basically add links to it, and href, once the link is added, your complete structure is done. Then what you do is you give it to add to DOM, and this function is your higher order function, because this is being executed twice. We'll learn more about it in the upcoming episode, but yeah, just stay with me and just try to digest the idea of why are we doing this, rather than how this magic function works or why there are parentheses. Just look at this idea. And this is the beauty of functional programming. And if I clean this up a bit or make it more realistic of how actually it will look like, it will look something like this. Your run function will be replaced by compose. You will have two side effects, which is add to DOM. And in fact, you can add any more side effects into it. Your compose function can just take X number of functions and run one after the other. And I'm looking at the time. I know I'm a little over time, but just stay with me because this is kind of the last slide. So yeah, so this is the idea here. We have addNav function. And one more thing which I have done in this slide, which is not in the previous slide, is that I have removed big data function, because it was for representation perspective, because your data is already right here. So I don't have to add one function which just takes the data and gives you back data. There's a name for that kind of function in functional programming, which is called as identity function, which has a purpose to use. You'll be thinking like, why do you want to have a function which takes the data, just gives back the same data? So yeah, these are the kind of interesting ideas functional programming has. And I hope with these two transformations that you saw, you were able to relate to this idea. And I want you to take a step back and think about the problems that you're solving. And another interesting aspect about functional programming is that it does not demand to replace whatever architecture you have right now in your application. For example, if you have, let's say, one React component, which is class-based, functional programming doesn't say that you have to get rid of it. Or let's say you are solving a problem using object-oriented pattern, it does not demand you to do that. If you mostly stick with JavaScript, because JavaScript is a very special language. It is based on prototype. It lets you do class-based things and it lets you do functional-based things. And that's the beauty of JavaScript. And yeah, you can do many exciting stuff with JavaScript. Now, let me go to the next slide. What next? Okay. So the key takeaway from this session is to think about your problems in terms of data, computation, and action. Now think about the application that you're building right now. Try to categorize what is a computation, what is an action. Can I make my actions lean? The API interaction, sending an email, interacting with Tom, all of these things are action. So if I have to give you one last example, I know the time is running away, but if I give you one last example, let's say you have a React component that you want to render on the DOM. So avoid writing a lot of business logic in that component, because your React component is basically a side effect because it is going to render something on the DOM. You must be like, okay, how will I avoid using computation in my React component? It is true, you can try, but you can still make your components a little leaner. You can rely on finding out common things that you can abstract away and things like that. So that is the key idea: data, computation, and action. I'll not take much of your time. And yeah, the last 2 points are emphasizing what I just said. Once your computation is isolated, you can use advanced function to pipe your transformation, which we just saw using compose function. And once your action is isolated, you can easily manage the timing, because you remember the example of loader and hitting an API, for example, the application loads, when are you going to trigger the API call? So that kind of timing is basically captured in your actions. So at this moment, I'll take a pause and I'll invite or welcome more questions. If you have one, leave it on the LinkedIn live session comment window, and I'll just look at my group if they are going to pass me those questions, and I'll try to answer them. And meanwhile that happens, you should check out the Accolite Digital LinkedIn page and the website for some great opportunities that we have. We are solving some exciting problems across many different domains. We are using different languages, different technologies, and it is just fantastic. And in case you were not able to leave a question for me, what you can also do is you can reach out to me at meher.howji@accolitedigital.com, and I'll be happy to help. And you can reach out to me in other channels as well. And yeah, it'll be interesting to hear your questions and help you out and look at different problems. So that was about functional programming, thinking in functional programming. In the next episode, we are going to go probably a little deeper. And until then, bye, and I'll see you in the next one. Thank you, everyone.